Morning everybody, welcome back. Today we're looking at Chapter 3 in the Math 11 course for acute triangle trigonometry. Some of the goals we're going to look at this sine law and cosine law. So we're going to build on what we learned last year in Math 10 using the three primary trig ratios, and we're going to solve problems using acute triangles. So in the first section, what we're going to do is we're looking at 3.1. We're going to be exploring side angle relationships in acute triangles. So first off, we're going to look at some of the terminology to recall from some of the previous courses we had. So most of our triangles that we're going to be dealing with now are going to be acute or obtuse. They're a little different from the right angle triangles. We'll talk about that, but we still label them the same way. So we label our angles if we label our angle capital letter A, B, and C, the sides opposite of those, so the measures, the lengths of, or the distance between A and C, so it's opposite of angle B would be lowercase b. So the same as we did in Math 10 when we did the trigonometry when we labeled that. Okay. Now remember, sometimes we don't just call it angle A, we call it angle CAB or BAC. And we do that because sometimes we have more than one triangle in an object given, right? So we have to really identify it not just with angle A, because they could have multiple angles, right? You could have multiple angles at the location of angle A. So just be mindful of that, all right? Some of the triangle properties that we should recall is the interior angles all add up to 180. We talked about that in the last chapter. The smallest angle is opposite the smallest side, and the largest angle is opposite the largest side. Okay, the bigger the angle, the larger the side, obviously. In right triangles, the Pythagorean theorem can be used. So anytime you have that and you need another side, you can use that. C squared equals A squared plus B squared. A right triangle has one right angle, 90 degrees, and two acute angles. An acute triangle has only acute angles, so all less than 90 degrees, right? So an acute angle is an angle that's less than 90, so an acute triangle has all three angles less than 90, okay? And an obtuse triangle, which we're going to talk about in the next chapter, we'll deal with obtuse triangles. And obtuse triangles, they have at least one, they have one angle, sorry, not at least one. One angle is more than 90, and then two other acute angles. Okay? So a little recall on the primary trig ratios that you learned in grade 10. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So if we have our reference angle here where theta is, then this side directly across from it is the opposite side. The side touching theta is the adjacent side, and obviously the side opposite of the right angle is the hypotenuse. So we're no longer going to have a hypotenuse when we're dealing with an acute or obtuse triangle, okay? Because a hypotenuse is opposite the right angle, okay? So just be mindful of that. Remember angle of elevation and angle of depression. Or angle of inclination for elevation. When looking up, the angle of elevation is the angle your sight makes with the horizontal. So here's the person here. They're looking straight at the horizontal and the elevation up towards the plane. That's the angle of elevation. And then you see this, the person on the hill here looking down at the car. So the angle of depression is with the horizontal. So left to right and down toward the object that you're looking. And I've said this many times in grade 10 and also this year in 11, make sure your calculator is in degree mode. All right? So while we're going to do that, what we'll do is we'll use our calculator and make sure that we are in degree mode. And if you're using one of our calculators from the school here, I'll show you how to put that in your calculator. So degree mode, a lot of calculators have DEG or D, or DRG maybe, I don't know, but I'll show you how to do it with my calculator now. So we have the sine of 30 and S to round to 4 places after the decimal, or 4 places to the right. So on your calculator, you'll notice that it says radian, so that means it's not in the correct mode. So in order to put that in the correct mode, you go literally mode here, MOD, it's the second row, second column, and it's the fourth one down, and it says radian, so you're going to go down, down until you get over there, and you'll hit enter until the dark is shaded over the degree. So now it's a degree, and you can see that it's changed up here to degree. So we can just hit clear, and then we hit sine 30, close your bracket, and it is 0.5 or 1/2. Okay? So we can say that sine of 30 is equal to 0.5, or as a ratio, you can call it 1/2. And once we start, then we're heading into the pre-cal 11, we're going to use mostly the fraction, and we'll talk about why that is, because what this means is the opposite side is 1 and the hypotenuse is 2 for a 30-degree angle. Now again, that could be 2/4, 3/6, any equivalent fraction would work as well, but again, we'll explore that more in pre-cal 11. Okay. Next, we'll do cos of 30. Now remember, 4 places after the decimal, that's if obviously it doesn't work, go right to a terminating decimal, which we had in the first one. Okay? So I'll do cos of 30, and I get 0.8660. So I'll enter that in. 0.8660. All right, and there is a fraction for this with radicals, but again, we'll talk about that in pre-cal once we get there in pre-cal 11. For those of you continuing on that course, and then the last one we'll do is tan 30. Close my bracket, enter, and I get 0.5735, but you can round that up for now. 0.577, and we'll put round the 3 to a 4. Okay? So that's how you take the sine of it if you're given an angle. Okay? Now if we want to find the angle, it's a little different. So hopefully you recall that if you're looking for theta, theta is going to be the inverse sine or the arc sine, depending on either one is okay, and inverse sine of the value 0.8660. Okay. So now we take the value of that, put that on a calculator. So we go second function sine, which is the inverse sine. That allows us to find the angle, 0.8660, close my bracket, and I get 59.999, right? So 59.999, or 997, sorry. And we're going to round to the nearest 10th place, so 1 place after the decimal. So we say that theta is equal to 60.0, because even though the 9 rounds the 9 up to a 0, which makes it 60 even, it said 10th place, so you still put in the decimal 0. Okay? Do the same thing with the inverse cos. So if it's cos theta equals to 0.7071, we do inverse cos, and then we say theta is equal to, we go to our calculator, second function cos, decimal 7071, close my bracket, enter, we have 45.00. Right? And that would be 45. Oh. Decimal 0 degrees. Okay. And the last one, we have the inverse tan. Tan theta is equal to 3.714. So the inverse tan of 3.714, so theta is equal to inverse tan 3.714, close my bracket, and I get 74.930, 74.930, right? So theta is equal to, and your final rounded version of your answer will need to have the degree sign. You don't need a degree sign until you're done. All right. So 3 leaves a 9 and a 9 and 74.9 degrees. Okay. So these are just making sure we're used to our calculator. Make sure it's in degree mode. I know many of you know this. We did it in 10, but I just want to do a little refresh. This could be some new notation for you. I think we all have an idea of the 4 cardinal directions as north, south, east, and west. North is up, south is down, west is left, east is right. But when we're somewhere in between with angles here, they can also be written, for example, we have n 30 degrees east, which means from the north, turn 30 degrees towards the east. So from the north, turn 30 degrees to the east. So the 30 degrees is as you see it here. All right. So this can be written as 30 degrees east of north. Same with the south, 45 east. So we have this directly in the diagonal here, 45 degrees. And it is 45 west of south. Okay? So turn 45 degrees toward the west, and then go south, and that's 45 degrees. And you could also say it as 45 degrees west of north. Okay? So that is direction notation. You'll have some of the word problems, and this is how they'll be referring to them. All right? Let's look at the law of sines formula. So the law of sines formula is given through the ratios of the length of A over the sine of A equal to the length of B over the sine of angle B, and it's equal to the length of C over the sine of C. And of course, you can take these and take the reciprocal of that. As long as they're all reciprocal, you can't just pick one, right? So it could be sine A over A equals sine B over B equals sine C over C. Now again, you can manipulate these formulas, as you're going to see when we do some of the questions. Like, you only need to have 2 of them, so like you would eliminate sine CC. All right? But that is the relationship for the law of sines formula that we're going to work with. Okay? You can use the sine law to solve a problem modeled by an acute triangle when you know the following. So you can use this law of sines formula when you have these scenarios. So when you know 2 sides and the angle opposite of one of those sides. So for example, we know these 2 sides, we know an angle opposite these 2 sides, then you can use the sine law. And if you know 2 angles and an adjacent side, you can also use that as well. Or if you know 2 angles and a side in the middle, you can use the law of sines formula for an acute triangle. Okay? And obviously, if you know the measures of 2 angles in a triangle, you know the third, right? So if I have these 2 angles, I know the third they add up to 180, which is quite obvious, right? Okay? And then we have the law of cosines formula. It's a little more complicated. We have a squared equals b squared plus c squared minus 2bc cos a, or of course we can switch the a and the b, right? So b squared is equal to a squared plus c squared minus 2ac cos b, or c squared is equal to a squared plus b squared minus 2ab cos c. All right, and when can you use this? And again, I'm going to show you one of these formulas solved for the angle A as well. We'll do those a little later on. When can you use the law of cosines? Law of cosines is when you have angle in between 2 sides, or if you're looking for an angle and you have all 3 sides as well. Those are the scenarios for the cosine. All right, so that's it for this lesson. And the next lesson, what we're going to do is we're going to start applying the sine law to a given triangle. So thank you for watching, and like I said, we're going to apply what we have learned in section 3.1 in the next lesson, applying the sine law. Thanks everybody for watching, and we'll see you in 3.2 in the next video.